Hi, in this video, I'm going to walk you through the light controller along with the light scheduler with integration from petstore application from a light example 4G. In order to start a cluster mode for both controller and the scheduler, we need Kafka sidecar, Docker Compose to start a Confluent platform. This is the Confluent platform running in Docker Compose. In order to start it, we just need to go to network-NT Kafka sidecar repository to run Docker Compose up. The Kafka sidecar is part of the open source, so you can go to the GitHub network-NT on organization to check out the Kafka sidecar. I don't want to restart it because it takes a little bit more time to start all different components for the Kafka broker and the Zookeeper. Once we have the Kafka sidecar Docker Compose up with a Confluent platform, you can start a light scheduler with 3 nodes. You can check out the light scheduler from network-NT organization, and within the root directory, you have Docker Compose YAML. So we just need to run Docker Compose up. We have 3 nodes started, and they're connecting to the Kafka for the stream processing. So we have node 1, node 2, node 3. Right now they are up running. The next step, we're going to start the controller in a cluster mode with 3 nodes. If you go to the network-NT light controller repository, you can see the Docker. There's a Docker Compose file here. You can start this. The light controller is open source. You can check out both light controller, light scheduler is open source. You can check out from GitHub. Let's start Docker Compose here. Docker Compose up. So we basically start 3 nodes. Right now they're up running, and it's connecting to the light scheduler, and both of them are connecting to the Kafka cluster. Yeah, in order to test this, we are gonna start a sample application to connect to the light controller. So the sample application is in the light example 4G REST petstore Maven single. This is on the GitHub, so you can just get it. What I want to do, I want to build this application using Maven. Clean install -p release. So -p release will basically create this fat jar so that you can run from a command line. So now we have a fat jar created. So you can just using Java -jar target server.jar. So once you can see, like, I'm gonna start this server. You can see that immediately there's some activities on the controller screen and the scheduler screen. So you see here, this petstore application registers itself to the controller, and the controller basically will schedule a task on the light scheduler. So those are the tasks we send, and every second you can see. Every 10 seconds, we're gonna have a health check task created in the Kafka topic. Then the light controller gonna process that target health check tasks and check the petstore application to see if they are still running. Now let's take a look at the API. We can see what's going on with the APIs. Let's check the scheduler. This is the first node of the scheduler. You can see we have a task, health check task here. It's for this petstore application. And if you go to the second node, let's say 8402, you should have exactly the same information available because all 3 nodes are connecting to the same Kafka cluster. This is 3. So you can see like on 3 different last scheduler nodes, we can see the same task definition over there. Now let's connecting to the controller to query the service. So controller, the first node is 8438. We just trying to figure out what the service is. So you can see we got the service petstore register here. If we go with the next node, it's 39. You have the same register service. The next node, it will be 40. And you got the same node. So basically, you can see we start the Confluent platform. We also start the light scheduler in the 3 node cluster. We also start controller with a 3 node cluster using Docker Compose. Once we got the entire platform started, we start the petstore application from a light example for G in the command line to register itself to the controller. So once we register, we did the query on the scheduler, also on the controller with different nodes. So this gives us overall like how to interaction between different components, especially for the control plane, how the control plane works in the cluster mode. Yeah, that's it. Thank you. Bye-bye.